Let's learn some basics of sequence. Sequence of real numbers to be precise. So, a sequence is an ordered list of elements, usually numbers, where each element is associated with a specific position in the list. Formally, a sequence can be defined as a function whose domain is the set of natural numbers, mapping each natural number to an element in the sequence. Bounded sequence. A sequence an is defined as a bounded sequence if there exists a k greater than or equal to 0 such that mod of an is less than or equal to k for all n belongs to the set of natural numbers. In essence, a sequence an is bounded if its range set is bounded. Note to students that supremum and infimum of the range set and the sequence are the same. If the range of the sequence an is finite, then there exists x belongs to the set of real numbers such that an equals x for infinitely many values of n. Monotonic sequence. Let an be a sequence of real numbers. An is called a monotonic sequence if either an is less than or equal to an plus 1, then the sequence is monotonically increasing or non-decreasing, or an is greater than or equal to an plus 1, then the sequence is monotonically decreasing or non-increasing for all n belongs to the set of natural numbers. Note that if an is strictly less than an plus 1, then the sequence is strictly increasing, and if an is strictly greater than an plus 1, then the sequence is strictly decreasing sequence. Moving on, a real number p is a limit point of the sequence an if for all epsilon greater than 0, an belongs to the set p minus epsilon to p plus epsilon for infinitely many values of n. And for the existence of a limit point, a theorem to be known is the Bolzano-Weierstrass theorem. It's basically everywhere when it comes to limit points, which states that every bounded sequence has a limit point. Definition of subsequence. Consider a map f from the set of natural numbers to the set of natural numbers defined by f of k equals nk, and let nk be a strictly increasing sequence of natural numbers. Then, for any sequence an, the sequence ank is defined as a subsequence of an. In short, a subsequence is a sequence derived from another sequence by deleting some or no elements without changing the order of the remaining elements. Let the sequence bx and sequence cy be subsequences of an. Then define S1 equals the set of x such that xn belongs to the set of natural numbers, and S2 equals the set of y such that yn belongs to the set of natural numbers. Then, sequence bx and sequence cy are complementary subsequences if S1 union S2 equals the set of natural numbers and S1 intersection S2 equals phi. Essentially, if you take out some elements to create a subsequence, the complementary subsequence is the sequence of elements you didn't take out. Limit of a point. Let an be a sequence of real numbers and L be a real number. Then we say L is the limit point of the sequence an if for any epsilon greater than 0 there exists m belongs to the set of natural numbers such that mod an minus L is less than epsilon for all n greater than or equal to m. Symbolically, we write it as limit as n tends to infinity an equals L, or an tends to L as n tends to infinity. The concepts of limit of a sequence and limit point of a sequence are related but distinct in mathematical analysis. As the limit of a sequence is the single value that the entire sequence approaches, while a limit point is a value that the sequence terms can get arbitrarily close to repeatedly, without necessarily being the sequence's ultimate destination. Algebra of limits to help you solve some problems on limits. Some important results. Limit of a convergent sequence is unique. If not, then how would you prove if it's not convergent? Next, if un is less than or equal to vn for all n greater than or equal to m, and limit n tends to infinity vn equals 0, then limit n tends to infinity, un equals 0. Since sequence un is less than vn and both are non-negative, thus vl will be 0. A bounded sequence is convergent if and only if it has a unique limit point. Every bounded sequence has a convergent subsequence, as it won't exceed a certain number. If each of the two subsequences a2n-1 and a2n of a sequence an converges to L, then an also converges to L. As they become complementary subsequences, also make sure to consider its contrapositive and write it in the comments. Let's see some questions. If you have answered all the questions, you have understood the topic. Happy learning!